Hey AP Stats, lesson 1.13 here, and we're going to continue with the lesson about the normal model, and we're going to specifically be looking at actually using the normal model to calculate percentages and proportions. So we are on page 6 of our notes. This page should have been completed in class. If you don't have this page done, it's because you were not in class. So I would highly suggest that you go rewatch the recorded Zoom that I have for today. The lesson I'm going to do right now will not make sense unless you have seen this first. And we will start below this green line. So we're just going to do A, B, and C here. So your best friend is 64 inches tall. How does his height compare to the rest of the males in the U.S.? What this references is the normal model that was given to us up here. And that normal model is that the average height in the U.S. is 70 and that there is a standard deviation of 3 inches. So what I just did here was I give you a notation, and remember that this big N denotes that we have a normal model. So we have a normal model where the average, the mean, is 70 and the standard deviation is 3. And we're going to denote those using this notation. Mu means our mean. That's a Greek letter. And then the Greek letter sigma for standard deviation. And you'll actually see that a lot of times in stats we can use these symbols as well. There is a difference between using mu and x bar and using sigma and s sub x. They both mean standard deviation, and these both mean the mean. But when we're talking about populations, and in this case we're talking about like the population of all U.S. men, we want to use these two symbols. Whenever we have a sample, like a small sample, say maybe of 30 kids or, 50 adults, that's when we would use this notation. So if you want to write that down so you remember, that's might be helpful. All right, so here we have a normal model, and our average is 70, and we have a standard deviation of 3. Our best friend is 64 inches tall. How does his height compare to the rest of the males in the U.S.? Well, just by looking at that height, I recognize that this is 64, so that's 6 less than the average. The average is 70, and 6 is actually 2 standard deviations. So our friend is actually 2 standard deviations below, which would give him a z-score of -2. But now when it says how does that height compare to the rest of the populations, well, it's pretty low. But statistically here, we actually want to give a percent to that. So what we're going to do when we're solving these normal model problems is first start off by drawing a rough sketch. Draw your bell shape. And in the middle, we know that the average is 70. And I like to put 1, 2, 3, 1, 2, 3, 3 dashes above and 3 dashes below, and each of those stands for a standard deviation. So you don't have to put the numbers in, but if I did put the numbers in, this first dash would be 67, this one would be 64, 61, and so on. I think it's helpful to just have them in there. We recognize what you should have learned in today's lecture was that anything that's outside of these 2 standard deviations is unusual. So what we're going to do is figure out where is 64? Where is that 0.64? And we know that that's actually 2 standard deviations below. So I'm going to put this right here. I'm going to say x equals 64. Now we want to see how he compares to the rest of the males in the US. So we pretty much want to see what his percentile is. What percent of the male population is he taller than? So I want to compare him to all the people below his height, all the males below his height. So I'm going to shade this part of our bell curve. And I want to figure out what percent did I just shade of this bell curve. This percent that I shaded is the percent of the population that he is taller than. All right, and this is where you would pull out your calculator to do a function. And this is going to be the first time you see that function, so I'm going to write out the steps up here so you have them. On your calculator, we're going to press second. We're going to go to vars. And from there, we're going to click normal CDF. And I will show you what that all looks like. And what this normal CDF does is it gives you 4 parameters that you have to put in. And these 4 parameters are going to be your lower bound, your upper bound, your average, and your standard deviation. So we'll pull out the calculator here in a second. But what we're going to have to do for this problem, we're going to have to use this function. And this is part of showing your work, actually writing in normal CDF, and then labeling your parameters and correctly writing down your parameters. So my lower bound, what I mean by this is I'm looking at my shaded region, and I want to see where is the lower limit. And for the upper bound, I want to see where is the higher limit, where's the upper limit. And one of these is pretty obvious, and I think the upper bound is a lot more obvious. The upper bound is right at 64 of that shaded region. The lower bound is a little more difficult to tell, because what's actually happening with this normal distribution is that the tails actually extend infinitely in both directions. So what I always tell students is that you're never wrong in picking a number that's just far out. And in this case, we're talking about height. So we know that height really can't be any lower than 0. So I'm going to extend this all the way out, and let's just say it extends out to 0. Let's say 0 is my lower limit. And you'll see different examples. Sometimes I'll use 0, sometimes I'll use like negative 99999. The difference there is really so small that it's not going to affect your answer. So in this case, I'm just going to use 0 as my lower bound. 64 is my upper bound, and that traps this shaded region that we want to compare. Now mu and sigma, that was already given to us in the problem as 70 and 3. So now I'm going to take this that we just wrote and pull out the calculator and let the calculator figure out what percent that is there. So let me open up Graph and Calc 83. And the steps were second, vars, and then you'll click on normal CDF. So first click seconds, and then click on vars, and bring you to this. And you have a bunch of stats calculations here. Make sure you click on the CDF. And you can see right below PDF, it's CDF here. You see the actual things that I mentioned here. You see lower bound, upper bound, mu, sigma. So it actually reminds you there. So I'm going to click on option number 2. And it even reminds you right here, which is awesome. Your lower bound for that problem we said was 0. Separate this by a comma. Our upper bound we said was 64. we want to look at all the males that are from heights 0 to 64, because that's where our friend is. And then the average height for males was 70 with a standard deviation of 3. Let's go ahead and hit enter, and we get a value of 0.02. And I'm going to turn this into percent. You can move the decimal over 2 times or just multiply by 100. So we have about 2.3%. So what that means here is, let me write this over here. What that means here in context is that our friend that is 64 inches tall, he's only taller than about 2.3% of the adult male population in the US, I believe. Yep, American men. So I'm just going to write a quick little sentence here. At 64 inches, my friend is taller than 2.3% of the US male population. All right, so that's one example. Next example, your father is 73 inches tall. How does his height compare to the rest of the population? So very similar. I always like to start by denoting what normal model we're using. We're still using that normal model with adult males. And I have 70 here, 3 standard deviations above, 3 standard deviations below. And this one, we're looking at our father that's 73 inches tall. So if 1 standard deviation is 3, he's actually exactly 1 standard deviation above. So here's our father at x equals 73. And how does his height compare to the rest of the males in the US? So again, for him, I'm looking at this shaded region below. I want to see what percent of the males in the US is he taller than. Well, just by looking at this, you can tell that I shaded more than half of this bell curve. So he's actually above that 50th percentile. He's actually above the average. So if I had to guess, I mean, maybe that looks like 60, about 60%, maybe 70. And that's where the normal distribution, the calculation that the calculator does, will help us. It'll do the best estimate given these parameters. So again, lower bound for this situation, you look at the left part of your shaded region, which is like over here. And we know that the tails actually extend forever. So I'm just going to write 0. And my upper bound, the right side of what region I shaded, is at 73. My parameters are the same. 70 as the average and 3 as the standard deviation. A good AP tip for you guys is that as you write this down, you need to let the AP grader know that you understand what each of these symbols, what each of these numbers represent. And the way you can let the grader know that is by putting symbols right underneath these. So it'd be as simple as this. You know that 0 is your lower bound. You know that 73 is your upper bound. You know that 70 is your mean, and 3 is your standard deviation. All right, let's pull out the calculator. So again, hit second, go to vars, normal CDF, and the only thing that changed here was the fact that our upper bound was 73 now instead of 64, sorry. And we have 84%. So about 84.1%. And what does this mean? It means that our father, at a height of 73 inches, is taller than about 84% of the population. Now, these were two examples where the lower bounds were kind of really stretched out. What you can also do is find specific parts of the normal model, and you'll see that with letter C here. So letter C says, what percent of the male population in the U.S. has a height between 69 and 77? So again, drawing my model. Sometimes my models look good, sometimes they don't. I don't think this is one of my best ones. That's all right. And we're looking at the values, the x values between 69 and 77. So 69 is pretty close to 70 here. And 77, I know that this first hash mark is 73, the second one is 76. So maybe it's about right here. And for this question that said, what percent of the male populations has a height between these two values? So I am looking at what percent of the normal model is in this shaded region. And again, this is just a normal CDF calculation. Normal CDF. And what is going to change here is now we have exact lower bound and an exact upper bound. You can see that my lower boundary, the one on the left, is 69, and my upper boundary, the one on the right, is 77. My average and sigma are still the same. We're still looking at the same normal model, right? I forgot to write that over here. This normal model has an average of 70 and a standard deviation of 3. And again, pro tip for the AP, let them know that you understand what these numbers mean. You know that's your lower bound, you know this is your upper bound, you know that's mu, and you know that's sigma. Alright, so let's go back here. And again, second vars, normal CDF, and our lower bound for this problem was 69, upper bound was 77. And we have about 62.1%. So if I were to write a sentence for this one, about 62.1% of adult males in the U.S. have a height between 69 and 77